grouped data. So if you want to come up with this, what are called the frequency polygon, the data actually that we want to use are what are called the grouped data. In other words, grouped frequency distribution can be displayed for you to come up with what is called frequency polygon. So we use what is called grouped frequency distribution. So grouped frequency distribution is the one that we are going to use. If you want to come up with this, what are called these polygons? Right. So, now, how do we yes? How do we
well, I wouldn't value my use my
what?
My yeah.
Yeah. Put it away.
It's a good
Do not.
If I do disturb the sound.
Fine. Right? How do we frequency polygon? So one of the most important elements for you to know how to construct this frequency polygon, having known that we are using this frequency distribution or grouped frequency distribution, is to develop what is called the mid-interval value. Right? When we look at mid-interval value, we are looking at now this distribution. Like if we say, assuming the age group that are sexually active, when we talk about these issues on what are called as this age, the sex workers. If you look at the age group, we can say it's from 10 to 20, right? Now, if it is 10 to 20, when you want to draw what is called the frequency polygon, what you have to do is you need to come up with the mid-interval value. So, like this one, you need to find the mid-interval value. Mid-interval value is going to be found at the center. It's going to be found at the center. Now, what do you think? How can we come up with this mid-interval value? What do you think what do you think? What's your suggestion if you want to come up with this mid-interval value? Having known that it's between 10 and 20, what would be the mid-interval value? Can you speak? What you do? What?
We add the upper, the lower bound.
And the upper. All right. So we add the lower bound plus upper bound or boundary. Then we divide by 2. Why do we divide by 2? Why do we divide by 2? We want to find the middle, right? We want to find the middle. Whatever you say is correct. We want to find the middle. We'll be correcting each other, don't worry. So you have to add the 2. So here is going to be 10 plus 20, which is what? 10 plus 20, divided by 2. 10 plus 20 is what? 30 divided by 2? 15. So it's going to be 15, which is the same as 2 goes here, 1, 2 here, 5, 2 here, 10. This 2 goes both. So 5 plus 10 is what? 15. Right. Now this 15 is that one is what is called the mid-interval value. Let's write down this one. Let's write down a small hint on that. Construct the frequency polygon. We consider the mid value All right. So mid value or the middle value is equal to lower bound plus the upper bound, then divide by 2. Right? In other words, the lower boundary plus the upper boundary divided by 2. Let's look at an example here. Let's look at an example. I remember I shared you the book, what I'm learning from your WhatsApp, right? Just open on that one. We're not going to take much of our time. Can you open that one? Which page is that one? From your, which page is that? Where there is example 1.10. Let's go to example 1.10. Example 1.10. Page what? Page 17. Look at that. Page 17. Good. Draw a frequency polygon to illustrate this frequency distribution, which gives the times taken by 31 competitors to complete a cross-country run. Time taken and frequency. So they are looking at time taken. So there is what is called, you have got time taken, and frequency. So they have written time taken from what? 25 less or equal to time, then less than 30. Then they have talked about 30 less or equal to time, then less than 35. It goes up to the last. Have you seen that one? Are you there? Yes. Everything that you are looking here, it is in your book. So even if you don't write what I'm saying, you can just look at what I'm saying from from the books that you have. Right. Let's look at that one. 25 less or equal to time less than 30. What it means there is that 25 is inclusive, but 30 is not inclusive. It means if you are to look at those numbers, it is from 25 to 29. 25 to 20 what? Because 30 is not inclusive. That's the meaning of 25 less or equal to time less than 30. 25 is inclusive. But if you go to the second one, you will discover that now the 30, here you are stopping at 29. But if you go to this one, you are starting from 30. Then the 30 is inclusive. This means that the 30 is inclusive within the time bound from 30 to 30 what? 30 what? 34. 30 to 34. All right? Then you go on and now there they are talking about frequency. Look at the frequency there. For the first one, frequency is 4. For the second one, frequency is 12. The other one, frequency is 8. The other one, frequency is 4. Then the last one, frequency is what? Frequency is what? 3. Right. So, what they are doing there is this. What they are doing there is this. If you look at that, they are saying it's time, and frequency. Just tell me what's the first one? The first one is what? 25 less equal to t less than what? 30. Another one? 30 less or equal to t less than 35. Another one? 35 less or equal to t less than 40. The other one? 40 less or equal to time less than 50. Another one? 50 less or equal to time less than 65. Another one? It is there, right? So the first one is what? The frequency for the first one? 4. Another one? 4. Another one? 8. Another one? 12. Another one? 4. The last one? 3. All right. Then, having seen that, the next thing that you have to do is, the question is, let's draw the frequency polygon. So the question is, can we draw the frequency polygon? Question. Draw the frequency what? Polygon. Draw the frequency polygon. How do we draw the frequency polygon? Now, if you want to draw the frequency polygon, you need to come up with a certain chart like this one. I need to have a chart of this nature here. You have what is called time. Another one? Mid-interval value. The other one? Interval width. Interval width. The other one? Frequency. Another one? Frequency. And the last one is frequency density. So, frequency density. Right. Now, if you look at the first one, time is between 25 less or equal to t less than 30. Then I'll go to 30 less or equal to t less than 35. The mid-interval, how do you calculate mid-interval? You are adding lower bound plus upper bound divided by. So the first one will be what? You add 30 plus 25 is 50 what? 55 divided by 2? 27.5. The second one? 30 plus 35? 65 divided by 2? 32.5. Is that? Let's go to frequency. Let's put for the first one, the frequency is 4, right? Then the second one, the frequency is what? 12. Let's go to interval width. The interval width. What is the interval width for the first one? You take 30 minus this one, right? 30 minus 25? 5. Another one? 5. You can go on and on and on, right? Then let's calculate what is called the frequency density. So here you can proceed. I'm not proceeding because you can do that. You proceed up to, you go up to the end. Let's go to frequency density. How do you calculate frequency density? So frequency density, what you are using? You are using which one? What are you using? Frequency density. So frequency density is equal to what? Frequency over interval width. So for the first one, what is the frequency? 4 over 5, which is 0.8. So here is 0.8. Another one? 5 over 12 over 5, which is 2.4. So the 2.4 is me. So you proceed, you can go up to the end there, right? Are we together? You can do up to the last, eh? Is there someone who is lost? Please, if you are lost, we are learning. We are learning. Tell us now why are you finding this? We are learning. Anything? Good. Okay. Which means everyone is fine. Now you can complete that table, right? Then having completed the table, the next thing is now we need to draw the frequency polygon, right? Let's draw the frequency polygon. So when you are looking at the frequency polygon, I will draw the frequency polygon here. The way you draw the frequency polygon, you do something like this. Right? Now, here is always frequency. You can either put it, this is because of frequency density so here you are putting frequency density, frequency FD, frequency density here. right? So frequency density, and down here, if that one is frequency density, down there you are looking at those ones, which is known as the time, right? So time, right? Let me emphasize here. Always frequency, whether frequency or frequency density should be this side. Any graph you are coming up, you are drawing, frequency should be this side. Whether frequency density, this side. But here, it is the time that we are talking about there. Now, we are starting this time from 25. So what you have to do is, you will start 25 to 30. So here is going to be 25, 30, 35, 40, 45, 50, you go up to, you can go up to sort of like that. And here, the frequency density. If you look at the frequency density, this one was, the first one was 0.8, right? The second one was 2.4. The another one, if you take from the book, 1.6. Another one, 0.4. Another one, 0.2. Another one, that's all. Right. So if you look at this frequency density, what's the highest number? It is a 2, right? Which means you can say this is 0 or 1, 2. Then you stop at what? 3. Because you already have got this, right? Right. So from 25 to 30, the midpoint is where you are having your cross. The midpoint. Midpoint is 25 to, the midpoint is 27 point what? 5. So you go to 27.5. So the midpoint 27.5. So this is the 25, 26, 27. So the midpoint is 27.5. It's where you are going to have your, so you look at, if this is 27.5, this is the middle of this. Then you take that one up to where there is, you correspond with this. Where there is 0.8. 0.8, you are just remaining with 0.2 to come up with 1, right? Therefore, 0.8 can be around. So this is 1, can be just next to this one. So this one is 27.5. Is this one. Then this is 0.8 can be here. So you draw a cross here. You do like this. Right? You go to the second one. So the second one, again, it is 32.5. So 32.5 is here. You go 30, 31, 32.5. This is 33 is here. 32.5 is half of this one, right? Is it? It's half, right? Yeah, 32.5 is half, so the half is here. So if you look at it, 32.5 is corresponding to 2.4. So you go to the 2.5 is half of this one. You go to 2.4 is around here. So it's like there. So you correct it's there. So you just do like this. If you go to the other one, if you look at your book, the other one is what? The other one is 30. The interval here is going to be 37.5, right? So here is going to be 37.5, and you go to the last one, it's going to be 1.6, right? So 37, 35, 36, 37. 37, you add just the 2 here, right? And then it is corresponding to 1.6. So this is 1. So 1.6, 1.5 here, 1.5, 1.6. So it's 37 is this one. So 1.6 can be around. I'm just assuming that this is 1.5, 1.6 can be there. Something like that. Right? It can be there. Then if you go to another one, the other one, it is what? The other one, the midpoint is 45. 45? All right. So 45 is corresponding to 0.4, right? 45 here. 0. What? 4. This is 0.5.
0.4 is below that. So it's, you go to 45 is here. 0.4 is here. So you put it like this. Right? Now, how do you draw the frequency polygon? How do you draw the frequency polygon? The way you draw the frequency polygon is not the same as what you do is you take a ruler, you connect from this point. You take your ruler, assuming that this is my ruler. You take your ruler, you connect this up to there, right? You use a ruler, you connect. You don't connect using free hand, you connect a ruler. And from there, you connect. Right? Then from there, you connect. Right? This what we have done here, that is what is called frequency what? Polygon. So this is your frequency polygon here. That is your frequency polygon. Right? So note that this, if you look at this polygon here, if you look at this polygon, it goes something. If you proceed, you're going to note it go like this one, right? If you look at this one, note that each tail, this is a tail here, right? Have you seen that this is a tail, right? Each tail is pointing to the left or to the right? The right. So the tail is pointing to the what? To the right. So you have to note that the polygon's tail is pointing to the right. So the tail is pointing to the right. If you look at that one, the tail is pointing to the right. Now, the fact that the tail is pointing to the right, we call it positive skewed. So, this is what is called positive what? Positive skewed. Positive skewed means, it means that the tail of the polygon is pointing to the right. Right? If you look at your diagrams, it means that the tail is pointing to the what? Right. Therefore, it is positive what? Skewed. Clear? Right. Yes.
So is it always the tail has to go to the right?
That's very good. That's a very good. Is it that always the tail has to go to the right? What the answer is no. That's why we'll see that sometimes the tail can point to the left. Sometimes the tail you can't determine whether it is pointing to the right or to the left. So we want to look at those scenarios, right? First, we are saying that this tail is pointing to the right. Therefore, this is what is called positive what? Skewed. That's why it's pointing to the right. Right? Then, it is possible. Go to comparative frequency polygon. Look at comparative frequency polygon. Go to comparative frequency polygon. The example 1.1, draw a frequency polygon to compare the age distribution of teachers in a 2-6 form college. There are two colleges there, college A and college B. Assuming you want to compare these two colleges based on, you want to compare the age distribution of teachers. The age distribution. Just let's look at the age distribution, right? In two colleges, college A and college B. So college A from 20 to 24, it is 4. 25 to 29, it is 6. 30 to 34, it is 11. Those distribution. College B, 20 to 24, 0. Those are the distribution. Then the question is, find out, draw the frequency distribution. You can do the same as what we have done, and then you need to find the mid-interval value. If you go to that diagram, so for you to work out the mid-interval value, you have to take upper bound plus lower bound. So it is 20 plus 25 divided by 2. That gives you 25.5. You do the same up to all those ones. Then you have got college A and college B. Those are the frequencies. And then you need to come up with another column where you are looking at, you have got frequencies. And then you need to come up with what is called frequency density. How do you calculate frequency density? Frequency density, you are calculating it by saying it is frequency over interval width. So when you do that, that's why they have got those two columns. Those two columns which they have drawn, they have just simplified from this what we have done here, right? And then they had to draw two graphs within the same graph paper. So you can look at those two graphs. College A, college B, those are the two graphs, right? So you can see how those two graphs are. So there is one which is, of which it is, there's another one which is skewed to the right. Then the second one, you can't determine where it is skewed. That's why, according to your question, you are saying, is it possible that the graphs have, the graph has to be skewed to the right? You look at that two graphs there, you will notice that the second graph, you can't see where it is skewed, right? Then it is taking us to this issue of what is called frequency curves. Let's go to frequency curves. To answer your question now we are going to frequency curves based on your question. Go to frequency curves. Let's go to frequency curves. In frequency curves, there are three types of skewedness. Major one. Of course, this one they have talked about that there are about 5 of them, but you can look at the first one. It is positive skewed, right? So positive skewed, the tail is positive. You can see where it is. That is what is called positive skewed. The first one, right? As this one is positive skewed. Positive skewed. The second one is negative skewed. The tail is to the left. Have you seen that one? Have you seen that one? Yes. Good. Then I'm not talking about the uniform. I'm not talking about the reverse J. Go to the last one, number 5, which is called the normal what? Normal class. Go to the other page. Page 21. It is normal what? Normal distribution. So the three major types of skewedness are positive skewed, negative skewed, and normal distribution. These are the major ones. Others are just subsidiary, additional, right? But the major ones are the 3. Positive skewed, negative skewed, and normal distribution. Normal distribution. Now, let me define that before we go to the other area. Let me define what is this normal distribution. What are these? Can I raise here? Right? We are saying the word polygon is a line. How would you draw that line? You use a ruler, right? But always, even if you haven't calculated frequency density, even if you have got only frequency here, you can have this frequency here. Again, it can work. Take note. Even if here you used only this frequency here, you put them here, frequency over time, it would have worked. You get what I'm saying? Or you use frequency density here, frequency density here. With this, it would have worked the same. The graph, but what you have to do is the most important thing. Draw your graphs using a ruler. Don't use a free what? Hand. You don't use a ruler. Here. Now, let's look at this distribution, and I will tell you what is the meaning. I will tell you the meaning. All right. Before I explain this, you have to know why is it important to know the skilledness. Why is it? Can you stop your WhatsApp? Why is it important to know the skilledness? Right. It is important to know the skilledness because sometimes some of you, not all of us, we are going to have our own business. Others, you be employed. Assuming you are working at Malawi Examination Board, Manebu, how do they know that the students have done well, they have done badly, or it is useful? Even if, assuming that the exam is very difficult, but the number of students going into public university will be the same. They will not say because it was difficult, then we have reduced the number of those going to university. They can't say it like that, right? Assuming that the exam was very easy, most of the students in Malawi scored 800. The number of students going to university is going to be the same number that they always pick. True or false? Yeah? If every year they are picking 3,000 students going to university, even if the exam is very difficult, they will not add the number, they will use the same number, right? Even if the exam was difficult, they will not say, let's write the exams again because it was difficult. Have they said that? What do? These people, they will do something like this. They will try, if the exam is difficult, they will try to draw a certain curve to bring all the results as a normal distribution. If the results was very easy, they will try to draw to make the graph to be on the normal what? Distribution. They will try to bring it as a normal distribution, provided what they want is they want to take the correct number of students going to university. Right. Let me just draw these three graphs, and I want to interpret them. Look here. I'll be bringing my rulers. I've bought rulers. I think I'll do that. Look at this one. I want you to tell me. I want you to tell me this. I'm saying these are skilled, right? They are called skilled, right? Right? What type of skill is this one? Positive skilled. Why positive skilled? The tail is pointing to the right. What type of skill is this one? Negative skilled. Why negative skilled? Okay, very good. What about this one? Normal what? Normal distribution. Why normal distribution? There is neither positive nor negative skewed, right? So it is normal what? Distribution. All right. So here is always frequency, right? Right? Assuming these are max. I wanted the red one. Here, what is this one? Frequency, number of students, those who have passed, and this one is marks, right? Here, frequency, and here, marks. Yes? All right. All right. All right. Now, if you look at this one, marks. If you go to this one, marks here, they are when you are going to this side, this side, right? You start. This is 0, right? Right. Assuming this is a marks, right? 20%, 30%, 40 what? Percent, 50 going there. If you look at it, the way this is, it is positive skewed because if this is an exam, what type of exam is this one? Right? If you look at this exam, a lot of students are here. Have they passed the exam or they have failed? Huh? They have failed because it is here. They are close here, right? So what type of exam is this one? Simple or difficult or easy? It is mathematics is very difficult. Right? It's very difficult because a lot of them, they have failed the exam. Therefore, this is a very difficult what? Exam. That's why it is skewed to the right. And this is positive what? Skew. A lot of them, they are here. Let's go to this one. It means they have run away from there here. What does that mean? A lot of them, they have what? Passed the exam. Well, this is a difficult exam or an easy exam? It is social studies, very easy, right? Social studies, very easy. Social studies, right? Very easy. That's why a lot of them, they have what? Passed. Now, these two scenarios, a lot of students failing, a lot of students passing. These are the two major scenarios that you have to know. This exam was very difficult exam. This exam was a very easy exam. That's why it is skewed to the left, which is known as negative what? Skewed. Now, if you look at always when you have got this incident here at Manning, if a lot of students have managed to have failed, what Manning will do, will try to bring this graph from there, will try to bring this graph to something like this one. What type of graph is this one? Normal distribution. We'll try to remove this. They will take this graph, they will remove it to bring it here where they are coming up with a normal what? Normal. What is the meaning of normal distribution? Normal distribution, what it means that the exam is a little bit not difficult. They will try to standardize, bringing all they will work out the marks and make sure that they will bring them together like here. For this incident here, what the man will do, we will try to bring another, we'll try to draw another, bring another graph, like taking this, bring it here. So here is going to be normally distributed. Normally distributed, it comes to that. That's why this is very, very important, because in this context is where when it is normally distributed, what it means is that it's easy for them to say, if the exam, at least some have passed, some have failed. It's this one. Or taking the number of students going to the university is this, which is called the normal distribution. We'll look at this type of normal distribution. But what I'm trying to mean here is that if exam is very difficult, Manebu will draw a normal distribution so that they will have a very good number of students going to the university. If the exams were very easy, so we are looking at these two scenarios where we are looking at whether it is negative skewed or positive what? Skewed. Negative skewed or positive skewed. That's why there is this word which they call it standardized. The exams were standardized. You heard about that, right? Standardized means if assuming that most of them failed, most of the students failed, like they got 5%, 7%, 10%. But if the passing mark was 50, they will try to play around with the numbers here so that at least, or even though that they have scored 5%, but they need to pass. They can give marks to this one. If the passing mark is 50, they may say, this one scored 5, or say what you want to say 45, 45, 45, right? So if they give 45 each one, so this one will be plus 45, plus here what? 45, plus here for what? 45. So 45 plus 5 is what? 50. This one will be 50 what? 52. This one is going to be what? 50 what? 55. Though they failed, but because you standardize, you notice that when we are announcing, we say that they have what? They have passed. But is it true that they passed? That's what they do with the money. Even though that people have failed, but they will try to give you marks so that they bring this graph to normal what? Normal distribution. I will not talk about pie charts. Go to pie charts. On pie charts, you can go read that pie charts. I will not talk about that one because that one you have already learned those ones when you were in primary school. But what we are now starting is now the issue of the mean. We are now starting the issue of the mean. That's what we are starting. We are starting the issue of the mean. Our next topic that we are looking now is the mean. We have to be together. We have to be together. Now, I'm saying, can you revise pie charts? You have to revise pie charts because the pie charts consist of 360 degrees. Can you revise the pie charts? I'm not talking much about the pie charts, but when you have got problems, please come back to me so that we can look at those problems on the pie charts. Revise pie charts. Let me now go to mean. But before we go to mean, we are stopping here saying there are three major distribution or skewedness. Positive skewed, negative skewed, and normal what? Distribution. And when it is positive skewed, what does that mean? Positive skewed, it means that the exams were very difficult. A lot of them have failed the what? The exam. If it is negative skewed, what does that mean? A lot of them have passed the exam, and the exam was simple. But where there is normal distribution, it means that the exam is normal distribution. The result is what? The exam was fair. Now, number 7. All right, normal distribution, the exam was fair. Then we are saying, we have concluded that even though the exam is difficult or the exam is simple, but those who play around with these marks, they will try to standardize, bringing the marks at one point or making the curve to be a normal what? Distribution. Clear? I don't want you, when I give you problems, when I give you questions, when I give you problems of this nature, I don't want you to fail. If I say draw the graph, tell me what type of skewedness is that. I don't want you to fail. Can you describe if it is positive skewed? What is it? What's the meaning? I don't want you to fail. If it is normal distribution, we'll look at these things here, especially if time will be there. We'll be looking at this normal distribution. Now, before we come to I come to the mean. What is it? What will determine this point? There are three things that will make you to know about where are you going to do this. These three things are what are called, we'll look at what is called mean, mode, and median. So mean, you learned about mean. Mean is average, right? You know that, right? So mean, you have got a mode, sometimes called a mode number. Mode is a number that is appearing most times, right? The number that has got more frequency is a mode. Number that is appearing most, right? Most. If one is appearing 20 times, that one is a mode, is a mode, sometimes called a model number. The name mode or model number is the same. Another one is the median. Median is the middle what? Number. So you can have number, this is the median is the middle number. You can count how many numbers there are, you can find what is the median. But what is the most important thing when you look at mean, mode, median? Make sure that you need to know how to construct a frequency table, or you need to know how to arrange numbers in order from the biggest to the smallest, in either ascending or descending order. You have to know that. You have to know that number one starts from 1, 2, 3, from the biggest to the smallest. You have to know that. Therefore, these graphs, whether it is positive skewed, negative skewed, normal distribution, will determine where is our mean, where is our mode, where is our median. It's only simple to this one. Normal these ones I think I will tell you. But this one, normal distribution, mean is there, mean will be here, mode will be here, median will be there. If you calculate mathematically, you find mean is the same as mode, the same as median. Know that that is normal what? Normal distribution. If you calculate mean, you find the answer. Mode, the same answer. Median, the same answer. Just know that is normal what? Normal distribution. But where mean, if mean is greater than mode, it comes to this scenario. If mean is less than mode is be greater, it becomes to this scenario. We'll look at those scenarios here. Let's look at mean. Let's go to mean. For the remaining minutes, let's look at mean. Right. Let's go to mean. For the 20 minutes remaining, let's go to mean. I don't know whether these things are making sense to you guys. Huh? Is it making sense? Okay. Pay attention quickly. You have to pay attention to what is this. Then thereafter, I think I will give you a simple work. Let's go to mean. Let's look at mean. The word mean is the same as what is called average. You know that, right? Aha, average is the same as mean. Right? Average. For example, find the mean of 2, 5, 7. Find the mean. Find the mean. So mean is equal to, you add this one, right? 2 plus 5 plus what? Divided by 3. So add this. 14 divided by what? 3. Your answer is that, right? Clear it? 14 divided by 3, you get that one, right? That's your answer. That's what you learned. Hey? Hey, sometimes you think when I ask and then you are quiet, It seems as if maybe you haven't learned that. In other words, what you are saying here is, in general here, in general, what you are saying is this one. In general, what you are assuming this one is x1. x1 plus x2 plus x3 plus xn. How many numbers are there? We don't know, right? Assuming there are 100 numbers, we'll add all those numbers, right? The last number xn, right? Then these are the numbers divided by those numbers n. Here, how many numbers are there? 1, 2, 3. Therefore, our n is equal to what? 3. That's why we here is 3. And how many numbers are here is this plus this. So the last number, our last number is this one, right? That's our thing is 2 plus this one divided by our n is 3. And this is in general to find mean. This is to find mean. So mean is that. To find mean is that. Right. Yes?
In there, is it okay to just leave it in proper fashion?
No, it's okay. It's okay. Whatever you can do is fine. Right? Whichever you can leave, I don't mind. Put whichever, whether you're saying it is 3, it is 4, and 4 and 2/3, no problem, right? Or 4 point, I don't mind. Or you leave it here. See, this is university, right? University, we don't penalize you much. Even if you put it there, even when you start and you leave it somewhere, it's correct. 10 to 10. That's what. Yeah, you start it knowing that at least what you are studying there is fine. It's good. It's fine. That's the university. Yeah, it's not that maybe we have to follow you up to wherever you want. Sometimes you are stuck somewhere. I can say, I think maybe you were stuck. Let me just push him or her, sort of like that. I give you the marks. It's not a problem. All right. In short, let me introduce to you this. The word mean, they use mathematics is a language. The mean is the same as this symbol here. It's called mean. So this is mean. When I write it, this means mean, right? This means mean. If you look at what we are doing here, before I come to that, what we are doing here, we are summing. This means summation. This means summation. It's a Greek word. It means sum. To sum is to add, right? This means to add. We are summing to sum all the x's, right? Or we are summing what? All the x's. We sum all the x's. We don't know what x is. Where if you look at it like this one, where our I is equal to, from this one, right? Our I is the first one. Our I, we look at from the first one to the last, which is our n, right? So here we are looking at our I as the first one, from the first one to out to n. What does that mean? This means this is the same as to sum. The way when you sum this, the way we are doing here, the first one is this one. If let me just do it here like this. Here, what we are doing here is, let me just define. We are adding it. Right? So we are adding here. This symbol means we are adding. It's a Greek word. Summation. Right? We are adding it here, right? So we are adding which numbers? Numbers. We are adding numbers, right? Our numbers are I. I'm just saying we are adding numbers, which is I. All numbers I. Which I is starting from number what? Number 1 to number what? N. And these are all x's. We are adding all the xi's. We are adding all the numbers. Our I started from number 1. We are starting number 1 to the. We are starting from number 1 to the what? What we are adding are the x's i's, right? But to find the mean, we are dividing this by, what? N. So this is the formula to find what? Mean. So another formula for finding mean, it is this one. Right? Therefore, mean is equal to, you sum all the xi's, I equals to 1 to n, divided by n. This is the x bar. I know some of you are saying, but sir, you are confusing us. Right? You are confusing us, sir. You have studied it very, very well. You are confusing us. Why are you confusing us like that? Guys, let's forget about this, what I'm doing here. Right? Can we forget this? Let's forget about this, what I'm doing here. Why can't we reduce this one to say, this is equal to sum of x over what? N. Which one is simple if I use this one and I use this one? Huh? This one is simple, right? You are adding all the x's divided by how many numbers are there, right? Take this one. And not this one. Right?
Yes, sir.
Yes, sir. Let's take this one and not what? This one. This one I'm just trying to say, it is the same as this what we are doing here. But it is complicated to your age. Your brain is going to burst. Right? So, to avoid that, can you take this one? We are adding all the x's divided by 8. We are adding all the numbers. How many numbers are there to find mean? Isn't it? In your exam, the exam that I will be giving you, you are going to write in the 3-4. They are just very recently. I will give you the formulas. And you will discover that the formulas I will give you for mean, it will be this one. Right? I will not give you this one. What does that mean? Why can't you add all the numbers divided by how many they are to find mean? Right? Even the skewed, I can just say positive skewed, negative skewed, it's like this one. Right? That's what it means there. Right? Let's look at this one. Let's finish off this example. No, we'll not finish off with this example. Let's look at this one. Open your books. Can you open your books? I don't want you to do that. I will not write. Open your books. Page 29. Example 1.16. The members of an orchestra. You know what an orchestra is? It's a band. Right? The members of an orchestra were asked how many instruments each could play. Here are the results. Someone said I play 2. Someone said I play 5 times 2, 4. Others 1, 1, 1, 2, 1, 3. Right? Right? Yes. Find the mean number of instruments played. How do you find mean? You add all those numbers, right? Mean you add 2 plus 5 plus up to the last one, right? Divided, how many are they? Count, how many are they? They are 30, right? They are 30. So you add all those numbers. 60. When you add it is 63, right? How many numbers are there at the end? Have you seen that x bar is equal to sum of the x divided by 8? That is the simple way. And what is the result there? 63 divided by? Which is go. So the main number of instruments played is 2.1. 2.1. Is it difficult? Difficult. Okay, good. Let's go to, let's have the same diagram. Let's have the same diagram and let's draw a frequency table. Number of instrument X and frequency. 1. Let's start with 1. How many times is 1 appearing there? How do you know? If you count 1 is 11, it's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1 is appearing 11 times, right? 2, are you sure? 3, 4, and 5. Aha. Now, if you look at that one, it's a table of X and table of F, right? So 1 is appearing 11 times. In other words, 1, 1, 1, 1, 1, 1, right? 2 is appearing 10 times. Open the other page. So the total number of instruments played can be calculated in an organized way as follows. X, what's the meaning of F? Frequency. What is Fx? Frequency times X. 8. All right. 1 is appearing 11 times. Fx is 1 times 11, right? 2 is appearing 10 times. So Fx means 2 times 10, which is what? 20. Then when you sum, so when you want to find the mean, where you, right, when you have got, this is a frequency table, to find the mean, you use where there is F and use where there is Fx, right? These 2 areas is where you are going to use. So what you do is you summation of F. It means you add the F, right? So when you add the F, it gives you 30, right? When you add the Fx, it gives you what? To 63. So the total number of instruments, find the mean is total number of instruments divided by total number of people. So the formula to find the mean, if you are given a distribution, it's going to be mean is equal to sum of what? Fx divided by sum of what? F. So sum of Fx there, it is 63, right? Sum of F is what? 30. So to find the mean, X bar is equal to 2.1. So Fx is the same as S. Fx, when you say Fx is the same as X times F. It's the same, right? 3 times 1 is the same as 1 times 3. True or false? 1 times 2 is the same as 2 times 1. True or false? That's what they say. If you write me Fx or Xf, it's the same. I will not penalize you, right? So in general, if you look at in general, the data is an organized frequency distribution where when you have got X is equal to sum of Fx over sum of F. That's to find what? Mean. What type of data is this one? What type of data is the one that we are using? Is it grouped or ungrouped? Ungrouped. And it's because of ungrouped, we call that one is discrete. The grouped is continuous. But here, because this data is not grouped, you see, if I ask you how old are you, 10, 15, how old are you, 10? That one is discrete. But if it is a range, that is what is called grouped data. But this is what is called ungrouped data. Assuming that now we want to use what is called the grouped data, let's go to example 1.17 as our last example before we go. Let's go to example 1.17. What type of data is that one? The speeds to the nearest miles per hour of 120 vehicles passing a checkpoint were recorded and are grouped in the table below. Speed 25 to 29, 21 to 25, 22 vehicles. 26 to 30, 48 vehicles. 31 to 35, 25 vehicles. 36 to 45, 16 vehicles. 46 to 60, 9 vehicles. Estimate the mean. Find the mean. How do you find the mean? So you need to have a table. So you need to have that table. Look at that table, the other one on page 31. Right? So you are going to have a table of speed, mid value. So the mid value is your x. You is that right? Mid value, you take lower plus upper divided by what? 2. The frequency you are given there. Then you are going to use fx. 23 times 22, the answer is there. Right? So you have to add the f and you have to add the sum of the fx, right? The formula, when you add the sum of fx divided by sum of f, the answer you are going to get is the mean speed for cars at that particular place. Clear? A bit? Come again. Who can explain that one? Can you? Someone can explain? Tamanda. Tamanda is around. Okay. Okay. Hawa. And where is Hawa? Online. I think the Gertrude is around here. Lorraine is around here. Are those online? Mess is around here. Mess online. Okay. Sarah, are you here? Sarah is not here. Okay. All right. What we are saying is this one. If where you have got grouped one, it's now time. Can we, as we are signing, last week it was 20 Jan. 31, eh? Last week was what? 31. Hey, what's the date today? 7/8. 7/08. 20 what? 4. 31 it. Can we let us signing as I'm finishing off. Listen. The type of data, that one is grouped. 21 to 25, they are 22. Right? 26 to 30, they are 40 what? 48. Then the question is find the mean of the distribution. Then your table is going to have 4 columns. Right? 4 columns is going to have what? Speed in intervals, right? Mid, it means that you are taking the interval, average of the interval, right? 21 plus 25 divided by what? That's why they are getting 23 there. Right? You do the same. Then the frequency you are given down, the frequency 22, 48, right? Then the column you are going to use, you will use the column of frequency, you add the frequency. When you add the frequency, 22 plus 48 plus 25, you are going to get 120. Right? 120 is the frequency. But our fx, you are taking 23 times 22, you put it there. 28 times 48, you put it there. Right? You put it there. 53 plus, 53 times 9, you put it there. You add that, you sum. Then you are saying sum of fx divided by sum of f. Then what we are getting, it is the mean speed of those cars. Understood, right? Good. All right. I think next week when we meet, want now to go in details now. Can we? I'm just yeah. We'll do it fast. We'll do it very, very fast. Can we, when we meet next week, at least we'll come on time. We'll finish something very, very interesting here. But for today, let's stop there. We would have gone further, but because I've eaten your time of doing other things, I wish you all the best as well. So you can switch. You can now. You can. You can. You can make it off. That one. Do that.